So this week is going to be our first week seeing Simulink. So the lab for this week is going to be pretty simple. It's just using Simulink to simulate a blinking LED on the Arduino. And then using that model to make sure that when you run it on the Arduino that you get the blinking LED. So it's kind of very similar to the first lab that we did for the Arduinos last semester, where it was essentially just making sure that everything is installed properly and we can move on to doing a more complicated one after that. But before you guys do that, and before we get into kind of a little bit more details of what Simulink is, why do we think Simulink exists is the first discussion question. Wanted to answer. Talked about it a little before. Yeah.
Is it cheaper?
So how is it cheaper? Not cheaper.
Simulink is like a Arduino simulator.
It's not just for Arduino, but it does have Arduino packages. So simulate Arduino. So why is simulating Arduino cheaper than what's the alternative?
I mean, you don't have to buy an Arduino pack.
As opposed to don't buy. Sure. But then in the end, what are we going to do with after we've simulated? You're gonna assemble it in real hardware. So we are ultimately going to buy it, but what can simulating help us decide?
We can use to help us do the most optimized solutions. Or that uses less wires or materials.
Okay, I like the materials. So like, don't buy 10 different Arduinos, right? To test them. Just you can see what would work by simulating the different kinds of Arduinos that are available on the markets. Maybe through the simulation you figure out, oh, I don't have enough digital pins with this Arduino, so I needed to upgrade to a different Arduino. So going back to what you said of kind of optimizing the materials, right? So it's cheaper, and this is one of the reasons it's cheaper. What else do we like? Why simulate?
Big differences.
Yes. So validation of, what should we call these? Maybe models. And this is going to be before production. Right? What else do we like?
Better to visualize on the simulator than in real life, because like in real life, the wires like kind of get messed up, but I would assume on the Simulink, it would be like more organized.
Okay, so you can use it to help organize large models. Like you're gonna lay it out on the simulator and have these connections. So rather than kind of just adding one thing at a time in real life. After you have it laid out on Simulink, you can kind of organize it to make it look better. And then use that to guide you when you're translating it into real hardware. What else? What else about simulating? Oh, yes.
Well, I don't know if it works this way, but like, can two people work on it at the same time?
Yeah. So similar to like GitHub, right? So this can be, what would we say? Let's just say teamwork. Right? Some people can be working on this part, and some people can be working on this other part that are, and they're independent of each other. We have these kind of subteams. This is still possible in real hardware, but it's more difficult, I guess I would say. Okay. What else? Yes.
Is, like, if you make a mistake, the consequences in the simulation, but, right?
So, find mistakes early and less problems. Right, when you find them. Alright, so these are all things that kind of are benefits of doing the simulation. I guess one other thing I have it on this side, right? So why are we using Simulink? We have this idea of from concept to operation. So it's going to help you model and analyze your design before you actually implement it on the hardware. So by using this virtual model to simulate and test your system, you can test early, right? Find those problems early, figure out what is the best hardware for your system. You can validate your design with the simulation as well as validating in real life after you put it on to the hardware. And you can generate your code for these different components and be able to deploy them onto the hardware. So you don't have to kind of wait until you have the hardware in order to start writing this code. And similar to GitHub, maintaining this digital thread and having it be able to be traceable, have those requirements listed out, see and visualize the system architecture, each components, and seeing your different code bases and your different test cases can be very beneficial. And by also having these systems that are simulated but are also in production, you can kind of have a better idea of when do you need to do maintenance and how can you do failure analysis. All right, so one of the things that we liked was that you can design and simulate your system before moving to hardware, right? So we can explore a wide design space, right? And test our system requirements in different domains. So we can quickly evaluate different design ideas through simulation rather than having to completely build and completely rebuild with a different hardware in mind. And this is very important for large scale system models. And we can also deploy simulation models for desktop, real-time, and hardware in the loop testing. So what else can we do with Simulink? We can design, analyze, and test system software architectures. So this is kind of going back to this point here. We need software for these different components. components. And by having the simulation for them, we can kind of have a better idea of what the requirements are for those different software architectures. And at the component level, we can have these different interfaces that we need to program. And this also goes back to having the ability to evaluate different models early on in the design process. So it's not just hardware, but also software. Okay. And one thing that is very popular that we discussed before was agile software development. So this is iterative design, right? So you're going to create the minimum viable product first, and then you can build upon that. So by having the simulation of your model, you can build on top of the simulation. What is the next feature to implement? What do I need to implement that? What are the additional tests that I'm going to do in the simulation before I go into hardware? And this is going to help us deliver these working software through simulations. Okay. And we can also respond to changing requirements very quickly by having this iterative design. Make sense? Okay. So Simulink, it is for MATLAB users. So that is why we learned MATLAB first. Okay. So we can use MATLAB and Simulink together to combine the power of textual and graphical programming into one environment. So we are going to apply our MATLAB knowledge to be able to optimize these parameters, create new blocks. We've done writing tests and these automation scripts. And this is possible. This isn't going to be something we are going to do with our small projects, but you can do thousands of simulations in parallel. But what we will do is analyze the simulation result. So here are some example Simulink projects. So it has been used in the past for artificial intelligence. So this system might be like your car's kind of a little bit more sophisticated cruise control, right? Being able to detect the lanes, how far the car in front of you is, matching the speed of the car in front of you. So you can simulate that system with Simulink, and has been done in the past. Wireless communication can be simulated with Simulink. Different control systems, so like for a plane, in this case, it looks like it was maybe controlled for a helicopter, right? Simulink can also be very helpful for signal processing systems. And then one of the most popular things it's used for is autonomous systems and robotics. And again, we talked about how this is very highly related to embedded systems. And then the advanced driver assistance systems goes along with this example of artificial intelligence. So this is just artificial intelligence applied to advanced driver assistance systems, right? So for Simulink, hey George. A model is a collection of blocks, and in general, these collection of blocks are going to represent a system. So in addition to creating a model from scratch, the previously saved model files can be loaded either from the file menu or from the MATLAB command prompts. So you can kind of have this hierarchical design space where you create a small block for your system. And that small block is going to be utilized by this larger part of your system in the Simulink design. And then you have these basic elements. So blocks and lines. And the blocks are used to generate, modify, combine outputs and display signals. So the blocks are your like actual components. And then lines are used to transfer signals from one block to another. So lines transmit signals in the direction indicated by an arrow. So like here, this is a step function. And the set function is going to transmit from here to here. And lines must always transmit signals from the output terminal of one block into the input terminal of another block. And then an exception to this is a line can kind of break off from another line. So like this is the output terminal of this block, right? But this is not an output terminal of a block, but essentially it's just this line here is also connected to the output of this, right? So you can break off lines from other lines, but the end of it must always go into the inputs of a different block. So here are our blocks. There are many different types. You can have a source. Sources are going to generate signals. So like this is generating a step function. You have sinks, which are used as outputs or kind of like displacing signals. You have continuous for continuous time elements, discrete for discrete time elements, and then you might also have these math operations. And then you have ports and subsystems. So subsystems are going to be this block that I've created that contains these smaller building blocks. That's the idea of the hierarchy in your design. But for the most part, we're going to have fairly simple designs. This is more of just introducing you to the idea of Simulink and getting you familiar with Simulink. And then maybe in future classes or in your career, you would be prepared to learn how Simulink is used in industry and in much larger projects, right? So this should be the end. Any questions on Simulink? Why does it exist? Why we're learning about Simulink? Next lab is making sure that everything is set up for Simulink, right? Okay. So that was it for today.